Well, we're talking about integration, and we're getting into a new integration technique called the integration by parts. And so I've got the integral of x times e raised to the x dx, and I've got the answer already stated here. Now, we're going to use integration by parts to get our answer. And the way this is usually stated, we're going to kind of use this, I guess you can call a formula here. It's the integral of u dv is equal to uv minus the integral of v du. So we want to identify what our u is and what our dv is going to be, and then we're going to plug it right on in right here. So I've identified my u to be x. And then what you're going to want to do is take the derivative of this, and so we end up with du is equal to dx because the derivative of x is just 1, but then we tack on a dx next to it. Okay, and we're going to identify our dv to be equal to e raised to the x dx. And what we're going to do here is we're going to take the integral of this, and I kind of leave this step off. It's kind of a traditional thing, I guess, to do. And if you can imagine, right, the integral sign right here, and then we take the integral of e to the x dx, and of course the integral of e to the x is just e raised to the x. And of course this here just becomes v. So I've kind of left that part off, putting the integral sign here, and then really you'd be putting the integral sign on both sides. But anyway, we leave that part off. Well, then we go back up to the formula, and remember it was uv, so it's going to be x times e to the x minus the integral of v du. Okay, so our v is e to the x, and our du is equal to dx. And of course what I'm going to do here is just rewrite the x e to the x minus, and the integral of e to the x is just e to the x. And remember, we don't want to forget our c, plus c.